Hey, this is Passy from Passy's World of ICT, the guy with the white hat. And today we've got a video for you that is all about checking algorithms manually using this technique called trace tables. And we're also going to look at a desk check trace technique as well. All right, so let's just show you what we're talking about here in this tutorial. So, what is a trace table? Well, trace tables, they're this way you can kind of desk check. You work it through with pen and paper, your pseudocode that you've developed, the algorithm, the logic for your program, and you can check out whether it's okay or not, all right? So that's the idea of the trace table, that you're kind of the human computer running the algorithm, the pseudocode yourself, and checking out whether it works. So we fill in all the results in this kind of table layout. Now these are very useful when you have to do exams. So if you're doing, if you're in Melbourne, Australia, doing VC software development or some sort of computer course somewhere else in the world, you need to know how to do this, because on the exams you don't have like a computer to work with. You've got to do it with pen and paper, and that's what these techniques are for. So let's just look at one quickly, a finished one. If we were adding two numbers together, we could have this algorithm here. So we just ask him to put in their first number with this code here. Then with the next lot of pseudocode, we're asking him to put in the second number. We're just going to initialize the answer variable, some numbers down to 0 here. And then we'll do the actual processing. We'll work out, okay, what was their first number plus their second number? Let's work out the total and just put out on the screen what the final answer of that total is with line 7 here, the last line. So kind of that's our pseudocode. Now you can manually check that one using one of these trace tables. First you need some test inputs, so you've got to decide on some input numbers to use. Now you might be doing this, or maybe an exam question has told you to use the values of 2 and 3, which we've got there, and we know they're easy ones. So if it's adding two numbers, 2 plus 3, well, the final output should be 5 when we desk check and work through this algorithm. So you end up setting up a table like this where you've gone through the program, or the pseudocode for the program, line by line here from 1 to 7. So it's 1 to 7 lines here, and you've worked through them, noting down each time what's happening to your variables. So in these columns we have the values of the variables, and this program had 3 variables: 1 to store the first number that they entered, 1 to store the second number that they entered, and 1 to store the answer, which is the sum of those two numbers added together. And when we finish all our tracing and we've got through all the pseudocode, the total comes out as 5. So we know what the final output should be. And it's looking good because our pseudocode generated 5, and we know 2 plus 3 is 5. All right, now you can also do like a desk check trace. Now we're just going to show you a finished example here. This was from an exam question where they wanted you to look at this pseudocode and work out what the final output from that algorithm would be, okay? Now the nice thing about a desk check trace is that you can have the exam question and just rule the table straight onto the exam paper and fill it out quickly with pen or pencil yourself, all right? Now that looks like a lot of stuff right there right now, but we're going to go through that step by step in this tutorial and show you. So we're going to do trace tables and we're going to do desk check trace, okay? Now, getting started making a trace table. Now we will just mention, we could have done this earlier in the course after we did algorithms. So it's probably important you've done the algorithms and pseudocode lessons in our course before you attempt this trace table one, so that you know what pseudocode is and what an algorithm is. Look, we could have done this earlier, but we thought what we'd do instead was we'd get you guys coding some programs, and we'd be using pseudocode in those lessons to design the program before we wrote the code. And that way you kind of get used to this idea, oh yeah, when we first design something, we kind of jot down some pseudocode, and then we can use that to then work out, okay, how do we translate it into Visual Basic, or how do we translate that into Python and get a working program? Okay, so often the real process though would be to have pseudocode, then do a trace table to check out the pseudocode's all right, then do the actual coding in Python or Visual Basic. All right, so making a trace table, that's the one which we're going to look at first. So step one, you number all of the executable lines of the pseudocode, so the ones that actually affect your variables and do things. If there's any blank lines, don't number them if they haven't got code on them. Step two, we actually kind of rule up that trace table. So we're going to be doing it in PowerPoint tables, but in the real world, you just have some pen and paper and just kind of draw this up like on pen or paper or on your exam paper if you're doing an exam, and you enter the start values of the variables. So work out what are the first starting up values, that the inputs that are going to go in, the test values. It might initialize the sum to 0 to start with and stuff like that. And step three then is to go through the algorithm line by line like a human computer, doing all of the processing and writing down as you go what the variable values currently are in that little table that you've drawn up called the trace table. Okay, so adding two numbers, we saw the finished version. Let's go through how you do that step by step, making a trace table. All right, so you get this pseudocode first, and that might be given to you on the exam question, or maybe for a project, you've written the pseudocode as you design and you want to test out to see, let's just check the logic and make sure this is good before we try coding it. So we number them. So we've got sort of putting some stuff on the screen here, some instructions, getting an input off the user. So we got 1, 2, 3, 4, 5, 6, 7, and all those lines are coded doing something. They're putting stuff out on the screen or altering some variable values or storing some variable values. So all of them get numbered 1 to 7. So that's our first step done of the 3 steps of making a trace table. And we also need to have our inputs, so they may have been given to us, or we might just have to figure out some inputs we're going to use ourselves. And for this one, we're using the numbers 2 and 3. So in step one, note down that you do have some input variable values to work with. All right, step two, we're going to go trace through just the first parts of the pseudocode to get what are the starting values for all of our variables. So this pseudocode, when we're ruling up the table here, we've got this first number variable, we've got a second number variable, we're going to store what they put in for the second number, and we've also got this sum numbers variable that's being initialized set here to 0, so that's another variable. So there's 3 variables, and so we make 3 columns on the trace table, okay? Just what each variable in the program is, find out what all the different ones are. There's 3 of them in this pseudocode, make columns for those. Now later on we'll also look at, you can make another column for what's going to screen output, and you can make another column for the results of loop tests like while tests, but this one's a simple one, we only need these 3 columns. So let's start analyzing. Line 1, it's just saying please enter the first number. So it's just putting that instruction out onto the screen, and nothing's happening to the actual variable values yet. So we're not doing anything in our table here for line 1. So now we go to line 2. Now line 2 in the pseudocode, that's where we get the number which they've typed in. So we ask them to put a number in here, they're actually going to type it in and we're going to get that number. And for this particular test case, that first number value is a 2 here. So what's going to happen is we're going to take that 2 that they've typed in and put it in computer memory. So the variable first number now has 2 in it, and we record that down. That's what line 2 has done in our pseudocode. Next we proceed to line 3. Now line 3 is just putting a message out on the screen and asking them to put in the second number. So for line 3, we've just got first numbers just staying the same. So it's just staying as 2. So we fill that out, it's still 2. Some numbers hasn't been done yet, so it's nothing. And we've asked for the second number, but we have not got the second number yet, so that's nothing as well. So down in line 4 is where we get the second number off them. We read that in and put it in computer memory. So for line 4, first numbers just staying the same at 2. We don't have some numbers yet, so that's blank. But second number, they've just typed it in, and they've typed in a 3 because for our test inputs, the second number value that's being used is the number 3. Okay, so that's kind of finished step 2. We've got all our start values. Well, no, we haven't quite finished yet, sorry. One more line, line 5, some numbers gets set to 0. So the answer is just getting initialized as 0. Now, why do we do that? Because we might want to clear it out from a previous run. So maybe a previous run worked out that the answer was 27. We don't want that sitting around in memory if we've just started doing the program again. So this is initializing is a common sort of thing. Just clear it out and set it to 0. So all three of our variables now are set with their starting off values. First number's at 2, second number's at 3, and we've just set with line 5 here some numbers to 0. So we've now completed step 2, which was to get all of our start values. Okay, now this table's now going to continue because we've got to look at lines 6 and 7 and fill in some more rows on the table. All right, so at line 6, this is where the processing happens. So it's going to add up that first number that they put in to the second number that they put in, and the answer is going to go into some numbers. So this is kind of, I don't know, it's written back to front. In maths, you would have just put some numbers equals first number plus second number, and that's how you could write it in your program. But kind of in this pseudocode, it's done with this backwards arrow thing. That's just a pseudocode convention. Don't blame me, it's not my idea. I'd rather just do some numbers equals first number plus second number. But anyway, we're stuck with what we got here. And what it's doing is it's saying, okay, add up the first number and second number, put the answer into some numbers. So 2 plus 3 will get added together here at line 6, and the answer to that's 5. So 5 is the value in some numbers. And that is line 6 completed, and now we just need to go to line 7. Now line 7 will be the last line, yay! Okay, so this last line says output total equals some numbers. So it's going to write onto the screen the words total and put an equals sign and leave a space. Then it's not going to put the word some numbers, it's going to go into computer memory and see what some numbers is. Well, some numbers is 5, and so 5 is going to get put in here. So on the screen, we'll have total equals 5. All right, so that's what the output is. So if you've been given like just this algorithm here, the pseudocode on an exam question, they said, what will be the output of this process if the first number equals 2 and second number equals 3? And you would have to kind of work that out, and the way you can do that is using a trace table. You'd work out the output from the program isn't just a 5, it's actually going to spell out to you total equals 5, okay? And we're done, and we're good. All right, hopefully that was okay. Pause the video if you kind of need a break or if you need to go back through that. And we're on to example 2. Now, once we get into loops, our trace table is going to get a lot longer because lines of code get repeated inside the loop. So we're not just going from 1 to 11 in this one. We're going to kind of do some repeats. So our final table, trace table, is going to be pretty long and pretty big. But we just do it one step at a time. We've got our 3 steps to follow, and we just follow them, and look, then we'll be fine. And yeah, just don't be upset because this one looks really long and hard. After you've done a few of these, they just get easier and easier like all things. So this one here, we're going to try out what happens when we put in 10, 3, and 20 are entered as inputs to this program. What sort of things are going to happen and what's going to come out on the screen. So there's the pseudocode we've been given, the algorithm that's going on here, the processing, and we're going to number that 1 to 11. So that's step 1, remember, that we number all of our lines. Okay, now our test inputs, we should note down what they are. Their first number 10, second number is going to be a 3, third number they enter in is going to be a 20. And let's start at line 1. So we've ruled up our table here. Now this time in our table, we're taking note of what line we're on in this first column. We've got what total is. That variable, what's that at the moment? And line 1 is setting that to 0. So we've filled that in the table to get started. Now, when there's a loop here, there's a counter for the loop, and the counter is going to go from 1, and then the second time we do the loop, counter will be 2. Third time we do the loop, counter will be 3. So we need to keep track of the counter. So we've got a column for counter. That's another variable. We're going to get some user input off them and store it in int value. So that integer value that they've entered in, value is another variable, and we're going to calculate a new value by timesing what they entered by 2 here with the star 2. Star means multiply. So we've got another one for the new value, and there is also going to be output on the screen. So in our previous one, we didn't worry about what was going out on the screen. We just figured out what was the final value coming out on the screen at the end. Here we're going to keep track of also the screen output. So that's kind of like another variable that's going to change over time, and that's our final column. So that's what we need. This is kind of a more full trace table than the previous one. We've got our lines. We've got 1, 2, 3, 4 variables in this pseudocode that we need to keep track of line by line. And we're also going to use this output column here just to show what's coming out on the screen each time. All right, so in the second line here, for counter 1, 2, 3, and you can see that's got a next lining up of it down here. And then all this stuff's kind of pushed across. So this is a for next loop. And what's going to happen is 3 times all of this stuff that's pushed in here, kind of pushed in, indented, all this stuff, this is going to get done 3 times. All right, and then we're going to stop, and then we'll drop down to do whatever is after that next. So classic for next loop in here, but we're on our line 2 at the moment. Line 2 for counters 1 to 3. Well, we're just starting out, first time coming into this loop, so counter is 1. So that we're on our first time through the loop, so counter just gets set to 1 in line 2. Line 3, output, enter a number value. So with this, just on the screen, it's just going to tell the users to enter a number value. So we couldn't fit it in there, we've just put enter a number. So that's what's happening with line 3. Some output onto the screen, enter a number, and total and counter are just hanging around at 0 and 1 from where they got set previously. On to line 4. Now to save space, you notice we've dropped our line numbers here. They're kind of getting all squashed against the side of the PowerPoint. We're having trouble making them all line up and stuff too. So we'll put them back on at the end, but we've just taken them off for now to speed things up a bit. All right, so line 4 is our next one. Int value is the user input. So we're going to get the user to put a number in. We're going to wait for them to do that, and that's going to get stored in int value. So for test number 1, the first number needs to be at 10, so the user's going to put in a 10. So we're going to store that inside value. So we note that down in our trace table here, where this column is tracing what is in the variable value, what's in that memory location at the moment. Well, the number 10 will go in there because that's what they typed in. And it'll also show that up on the screen. So we also put it in this output column as well, that there's going to be a 10 there showing up on the screen. And on to line 5. Line 5, now line 5 gets interesting because we've got an if statement here. Now we need to check at line 5, is the value, int value, if that's less than 10, then we're going to do some stuff here that's all pushed in and indented, these 3 things. But if it's not less than 10, all that stuff will get ignored and it'll just jump down and finish and go to next. All right, so it all depends on what our value is and whether it's less than 10. That's where we can go to our trace table now and have a look at value, int value. Well, that's 10. That's actually the same as what's in the pseudocode. That's a coincidence. So 10 is not less than 10. So this won't be true because we've already got 10 there. We're not at less than 10 for our value. So what'll happen there is that because of that, this stuff won't get done and it's just going to go down to this next here. And the next will say, okay, well, let's just jump up to the top of the loop to do another repeat because we've finished doing number 1 and we need to jump up here and check whether we and do the second one. Okay, so we've done number 1, we need to do the second loop. All right, so we're back up here again doing the second loop for the counter 1 to 3. So now we're on counter number 2, we're on the second loop. So counter will get set to 2. These other things are all staying the same here. All right, so that's line 2. Then we're at line 3, line 3. Line 3 is going to do the same sort of thing again, ask them to enter a number. And line 4 we're doing for the second time now because we're in the second loop. And this one that was going to be the user input for the second number, the second loop, was going to be a 3. So value's now going to get 3 put into it. So it won't have 10 anymore. It's going to change to have a value of 3. And that 3 will also be put out on the screen when the user types it in. Okay, so on to line 5. If the value is less than 10, do this stuff inside the if statement. Okay, so let's check out our value. Our value is 3 now because they just typed in a 3 for their second number. Now 3 is less than 10 on this if statement. So that's true. So that means we're going to go in and do this stuff this time. We're going to do these 3 lines of code here. And so that'll be the next thing we do. We won't be jumping down and jumping back up. We'll actually just be going to line 6 right here. And this one says, calculate a new value by taking what they've typed in, the int value, and timesing that by 2. Star means multiply in coding and pseudocode. So, okay, they've typed in a 3 here, and if we do 3 times 2, we're going to get a 6. So the new value, which we write in the new value column here, is 6. So that's line 6 completed, and we got a 6. Oh, we've got a lot of weird stuff going on here. 10s matching 10s and 6s matching 6s, but that won't always happen. It's just coincidence. And let's not get 666, the devil's number, and have that issue again like we did in the last video. Now, the next one here, we're on to line 7, and line 7 is going to do some output, and on the screen it's going to output what that new value is that we just calculated. Well, we just calculated that new value is a 6, so that's going to get put out on the screen. So on the screen, you'll just see a random 6 appear, put out on the screen. So now we're ready to do line 8. Line 8 is going to do something to the total. So remember, total was way over here in our first column, and at the moment it's 0. And it's going to take that total value of 0 and add on what int new value is. Well, if we check out new value, it's at 6. So it's going to actually do 0 plus 6 and work out that 0 plus 6 is a 6. So at line 8 here, total's now going to get updated to 6 because that's what this line's doing. It's saying take total, which was at 0, add on int new value 6, so it'll do 0 plus 6 and work out that this is 6, okay? So that's the actual thing that's happening on line 8. The other variables are just staying here the same. Counter's still 2, we're still in the second loop. Value's still at 3 and new value's still at 6, but we've updated the total, did some processing of that and turned it into a 6. All right, on to line 9. Now line 9 is the end if, so we've just finished doing the if. We're going to go down to the next now at line 10. That jumps us back up again to start the loop again because all the looping happens between the for and the next statement. So all this stuff that's pushed in is the looping stuff. And so now we're up here and we're on loop number 3. We've done number 1 and we've done number 2. So our counter here will update to 3. So when we jump up here, we're now up to counter 3. All our other things stay the same, but counter has changed. So we're in our third and final loop. Good, because we're running out of room in this trace table, so we need to finish up soon. Okay, so we'll jump down to 3 from there, third time in the loop. Enter a number, so it asks us to enter a number. We get a user input. This time the third number is a 20, so 20 goes into the value in memory, so it's not 3 anymore, it's now 20, and that'll be reflected out on the screen as they type it in. Then line 5 is the int value less than 10. Well, let's check that out. We'll go to the value column in our table, and it's a 20. Okay, 20 isn't less than 10, so that means we're not going to do the loop stuff. We're not going to do this. We're going to jump straight down to the end if, and from there we'll go to the next. Now, on the next, usually the next is jumping us back up to the for, but this for statement said to do the loop 3 times, and if we check our counter here, we're actually on our third and final time through the loop. So we're not going to jump up and do it anymore. The logic says that after 3 loops, there's no more nexting. Okay, so that said 1 to 3. We're in our third time through. We've been 3 times through, so we don't jump up and do any more. That's it, we're finished. So all of those lines are finished, and finally we can move on to line 11, the last line, which is good because we've only got any room here over on the left to fit anything into our trace table. Clever how I planned it like that, isn't it? Okay, so we've put the numbers in, we've kind of squishy squashed them in now as well to show you what numbers it was doing in the pseudocode each time. And this slide's kind of big and complicated, but it's a summary of everything that's happened. But basically down at line 11 here, it's just going to output total. So it's not actually going to write any sentences about it. It's just going to go look what is in the memory for total. So in the total column, right down the bottom here, we've got a 6. So it's just going to put a 6 on the screen. So you'll just see a 6 come out on the screen. And that's it finished. Now, something to notice, we had 3 repeats because we set up a 4, 1 to 3 here, a 4 next. So I was going to do this stuff that's pushed in from the side here, lines 3 down to 9, they were going to get done 3 times. And once you've got your line numbers in, you can actually check that out, that happened. And we can see this of our line numbers. See, it did 3 and 4 here, the first time through the loop. Then it did 3 and 4 again, asking for a number. And then it also did 3 and 4 again down here. Okay, so there's 2 lots of 3 and 4 pairs, so we know it did it 3 times. So that's just something to check, a way of just doing a quick check on your table at the end. If we were going to be having a 4 next that was 3 loops, 3 repeats because of this 3 on the end, just check out in your line numbers for your trace table that you have actually got 3 lots of stuff. And we've got 1 lot of doing lines 3 and 4, then another lot, which was when the counter was 2, and then a final lot of doing the same thing when the counter was 3. So it has done its 3 repeats. So we can be pretty confident that this trace table is all good and all done. And take a big breath and a sigh of relief because it is now finished. Now that took us a while, but look, doing this on pen and paper, quickly drawing it up, it's going to be a lot quicker than making PowerPoint slides and doing little red arrows and stuff like that. You're not going to do that when you're working one of these out. You just get some pen and paper and jot down your variables, rule down your columns, and start reading through the pseudocode like a human computer and putting the numbers in. So why learn to do this painful long thing of trace tables? Because we saw back when we did our algorithms lesson, if you go back to our algorithms and pseudocode, we saw that once we had an algorithm, it was very easy just to make a Visual Basic console program, put the lines of code from the algorithm in there and just bung in a few test numbers, put a few test numbers in, try it out a couple of times and go, yeah, that algorithm's working fine. We're getting just what we expected to get. And you could do the same thing with Python too. If you go back to our lesson on Python and algorithms, you'll see we had like an algorithm. We could easily just put it into Python because Python is so cool. It's just like English language, almost identical to what we'd written in the pseudocode. And you could check out whether it was working in Python. But, however, and there's always a however, you see, when you've got an exam to do, like the VC software development exam here in Melbourne, Australia, there won't be any computer, so there won't be any Visual Basic console program, there won't be Python, there won't be any way of checking the algorithm. So if they're giving you some pseudocode and ask you questions about it, like how many times will this have repeated loops, how many loops will this pseudocode do, what will be the final output from this pseudocode, we're expecting this pseudocode to, divide everything by 2 and then come up with answers. Is the pseudocode working correctly? Because there might be some mistake in it. And when you do your trace table, you'll find, hey, that didn't divide by 2 properly. And then you have to find the line of kind of pseudocode that's wrong. So it's no computers on the exam. So you've got to be able to do trace tables and manually work it out with pen and paper. But at least on the exam, it's going to be much faster to just draw up some columns there and do some quick calculations and working out. Not like you have to type it all into PowerPoint or Word and set up tables and stuff. Now, the exam question may not ask you specifically to do a trace table, all right? So you will need to work it out some way, but you may not have to use the trace table way unless they've given you maybe a partially completed trace table where you've got to finish filling in the trace table, or it specifically says in the question, create a trace table, and they give you a big blank section of paper on the exam there, space to do it. You can use this other way of doing it, which is desk check traces, okay? So this is the second method. So if you want to kind of just pause the PowerPoint, pause the pause the video now and take a break to just think about trace tables before we do part 2, which is on desk check traces. Okay, so you're probably thinking, why you teach me more things? You know, I'm struggling with trace tables. I hardly understand all that mumbo jumbo that we just went through. Well, look, hang in there. Desk check traces are really good because they're kind of quick. I think they're quicker and easier than doing the full trace table, but they kind of do the same sort of thing. Now, on an exam question, you can use one of these desk check traces, which is a little bit faster to do, unless, like we said, it specifically is asking you to fill in some trace table they've started or to make your own trace table. All right, so in the desk check, we put the lines of pseudocode actually as the rows in the first column. So we don't have line numbers going 1, 2, 3, 4, 5, 6, 7 down the side. We actually have the lines of pseudocode going down the side to make the rows. And for the column headings, we don't put the variable names, we just put what loop number we're in, okay? So which loop are we currently doing in the program? And you'll see that now in the example. Now, I learned how to do this from this great presentation PowerPoint. Mark Kelly is a legendary IT teacher. He's retired now, but he's got a site, vceit.com. Really suggest you check it out. He's got a lot of useful stuff there. Big shout out to him. But yeah, we had a look at some of his stuff, and that's where we saw these desk check traces, and it's a much better way of doing things. So let's have a look at an example. It's an exam question. It's from the 2015 software development exam. But if you're in other countries, like if you're in the UK doing GCSE computer science, you'll find it's pretty much the same as our software development course we got here in Australia. And you'll get questions like this as well. So they've given us some pseudocode here, and that was actually written up the top, but on our PowerPoint slide, it wouldn't fit there. And this was the question, what is the output from the pseudocode shown above? Well, it's here to the side, not above. Is it 4, is it 9, is it 16, or is it 25? Okay, so a couple of ones are small, if you were guessing, and a couple are big. So it's not like there's kind of the odd one out you can eliminate or anything straight away. You're going to have to do some working out to get this. Now, this desk check trace is really a nice way of doing it. It doesn't say you have to use a trace table in the question, so we're happy to do it by whatever means we like. We could just guess, and we've got a 25% chance of getting it right, or we could actually do some working out and get a 100% chance of getting right. So let's go with the 100%er here. All right, now straight onto the exam paper. These are photos I kind of took with my phone as I did this. What you can do is you can just rule some lines across. So where every line of our pseudocode is, just make a horizontal line going right across the page there. And then we just make some columns and make them wide enough to do some little calculations. So I don't know how many times this while loop is going to go because it looks a bit tricky with the calculating here. So let's just sort of do 1, 2, 3, 4 columns. It's pretty likely it's going to be like 5 or 6 long, but if it is, we just have to squashy some more in. But let's just have a go, just set up 4 columns. So just rule all that up directly on the exam paper quickly with your pen or pencil. And we're going to start filling this in. So what's happening at the start of the pseudocode here is it's setting A to be equal to 3, B to 5, and for the condition, we're checking out whether A, which is a 3 here, is 3 less than 2 times B. Well, B is 5, so is 3 less than 2 times 5? 3 versus 2 times 5. Okay, 2 times 5 is 10, and 3, yeah, 3 is smaller than, is less than 10, so that's true. So we've got our 3 variables here, kind of the checking one, the A's and the B's. So we've actually kind of done the same thing as step 1 was in our trace table, but we've done it in a different kind of layout here. So we've quickly done that and got the starting values of our variables. So we're now ready to fill in a bit more. And we've filled in a bit more here. We've filled in all this stuff here, the actual kind of processing that's happening. So they tell you C, well, C has to be whatever happens when you multiply A times A. Okay, so we go up here and check it out. A is 3. Okay, so we need to do A times A. That's 3 times 3, and answer for that is 9. So, yeah, C is now going to have a 9 in it. That's going to be what's in computer memory. So kind of put boxes around there just to emphasize that. Now this is saying A, okay, well, whatever's going to go in memory slot A, it needs to be A plus 1. So we take our 3 here, 3 plus 1, that comes out as 4. So A, memory variable A, is now going to have the value of 4 in it. So just kind of box them up. And B needs to be B minus 1. So B was 5 originally in its little memory box, but now it's going to be 5 minus 1. So 5 minus 1 is 4. So B is now 4. Okay, so that's what we've done. The while condition is going to be true, 3 is less than 10. And so all these loop lines here are going to be done. So we need to go through and do them like we did in recording the values. All right, so those ones are done, and we're down to the end while, which is kind of like the next is in a for next loop. That's the one that either lets you finish or it flicks you back again up to the top of the loop. All right, now the end while makes processing jump back up to line 3. Okay, so just like a next statement in a loop does, the while here, we jump back up to this one, and now we're going to kind of be doing that same calculation again and checking out whether it's true or not. So let's get on to doing that. So we check it out. A less than 2 times B. Well, A and B have changed. A is now a 4, so is our 4 here less than, and the algorithm pseudocode saying 2 times B. Now B is now a 4 here, so we need to fill in 2 times 4. 2 times 4 is 8. Yeah, 4 is going to be less than 8. All right, so that's true. And because it's true, that means we're going to do these indented, these pushed in lines here that are part of the loop. So we need to do our CAB calculations again, but they got different numbers this time because C, remember the formula is use A times A, but A's changed. A is now a 4. It's not 3 anymore like it was at the start, it's a 4. So we need to do 4 times 4, that's 16. For C, A is A plus 1, so grab this, it's a 4, do 4 plus 1. A's now become 5, that's its latest value. And B, for recalculating B, it's subtracting 1 here. So B was at 4, but now we need to do 4 minus 1. B's now going to be at 3. Okay, so for loop 2, C, A, and B are having their values changed, and the value is going to be 16, 5, and 3. And then the end while here is going to flick us back up to the start of the loop to see whether we're going to go for a third time here. And we'll go for a third time if that condition is true. So let's check that out. And in loop 3, if we now take our A, which is now A is where? Where is A? A is here, it's a 5. So is 5 less than 2 times B? Well, B is 3, so is 5 less than 2 times 3? 2 times 3 is 6. Yep, 5's less than that. That's true. That means we're going for a third time. So we have to calculate C, A, and B again using whatever the latest values of 6, A, and C, A, and B were here. So remember, C is A times A, so I'm going to do 5 times 5 is 25. Then you plus 1 to get this for 6. And remember, B, you're taking the current value of B, which is 3 minus 1 is 2. So there are our latest values for C, A, and B. The try loop, again, will make us go and try a 4th time. Now, when we try the test the 4th time, A currently now is up to a 6. And so we're checking, is 6 less than 2 times B? All right, so we've got a 6. Now, 2 times B, that'd be 2 times 2, because we got a 2 in there, which is 4. 6 is not less than 4, so that's now become false. So we're not going to go and do all of this. So we're only doing this while this statement's true. And when we've got up to this stage here, we check it out. 6 is less than 2 times 2 is 4. No, 6 is not less than 4. 6 is actually bigger than 4. So that's false. And once it becomes false, we don't do this stuff anymore. It just zips straight down, skipping all those steps to the end while and the loop's finished. And so now that spinning round in the loop, repeating sort of stuff's finished, we can finally get on to the next line in the program, which here is 1 line, but it could be several lines after this, but it's just 1 line here, print out the value of C. Okay, now if we go to our little memory recording here, the latest value of C was 25, so it's going to print out 25, okay? So because that was false, we skipped doing the loop and we got to the end and came down to here. That's just going to put out the number 25. So the answer for this, after all that work for question 3, is the answer is 25, the biggest number. All right, so that was the answer, and that's because we did all that work, and when we got to this final loop 4, we didn't actually do a loop 4 because it turned out false, and then we dropped down to our final line of code and printed out the 25, which we had here as the value of C. All right, so whoa, that was a lot of work to do one multiple choice question, which is only worth 1 mark on the exam. But boys and girls, ladies and gentlemen, if you read the question carefully, if you had a quick look at it, it can also be used for a couple more answers. So it's not going to be all lost, all that working out we just did. It says to use it for questions 3 to 5 here. So we've done question 3 and we got that right. And we're on to question 4. Now, question 4 said, how many times is the while loop executed? Now, you might be thinking, oh yeah, there were 4 columns that we ruled up, so it was 4. Think about that carefully. Remember, when we got to trying out to do loop 4, the condition was false. So we actually skipped all the steps in it. So we actually didn't do a loop 4. All right, we only had 3 times where we went through and did calculations and changed A, B, and C. So I actually only looped 3 times. We only did processing 3 times. So the answer for that one is 3. That's how many times it was actually executed, which means stuff actually got done, like we actually did those mathematical formulas and changed values and stuff. Now, question 5, it's saying in the pseudocode above, which is actually here to the side, these 2 lines, these first couple of lines are examples of which sort of control structure. Are they a repetition, a selection, a sequence, or an iteration? So we're talking about these 2 guys here. Okay, well, they sort of come one after each other in the side the loop, and they're kind of doing arithmetic or maths formulas or algebra substitution. They're just doing some processing, all right? So we'd call them just processing steps, but hey, that's not one of the answers. They are in sequence one after each other though, and just doing stuff, and they're not actually a repetition. Repetition and iteration mean the same thing actually, A and D, and that means doing repeats. And that's like your while and your end while. So if they're asking about the while and the end while, A or D would be okay. Selection, that's when you use an if statement to select stuff, or a case statement. So these guys aren't selection, they're actually just sequence is the answer, okay? So the answer is C. Like we said, if you've got an if, end if they're asking about some lines of code, or they had some if or else if lines they're asking about, or some case lines, then your answer would be B, selection. And if they're asking about what does this while A less than 2 star B, what sort of structure's that with its end while buddy down the bottom here? That's a repetition or an iteration type structure, that one, okay? So sequence, they're just doing some mathematics one after each other in sequence. So that was the answer for that one. So yeah, for working all that out, you kind of get 3 marks on your multiple choice. And I think on the software development, there's like 20 questions. So yeah, rule that up, work it out, you'll get 3 marks for sure. All right, your turn. So here's one for you to have a go at, and you can either do this by trace table or desk check. And yeah, I know you're really excited. Pencil and paper working out. Wow, this is just like maths, and it's got stuff in it, formulas, just like algebra. Why can't we just be writing programs and doing coding? Yeah, well, this is part of the course and part of all computer science courses. Look, they do the same thing in the UK when they're doing their GCSE computer science. So yeah, you got to suck it up and do it, kids. So it's your choice. You can use a trace table or make a desktop trace, but we want to find out what is the final output? What will come out of this loop at the end? What's going to be on the screen when all that pseudocode is finished executing? All right, so pause the video now and try that. We're going to come back later on and actually show you the answer, but you should take your turn now and try it out and do it yourself, okay? So pause the video and do that. All right, so hopefully you got through that okay, and we'll show you the answer soon. We decided to just do a trace table for ours, so we just numbered the pseudocode 1 to 7 there because there were 7 lines of stuff that did things. So we're going to do a trace table. So we've set up having our line numbers, having our variables are value 1, value 2. We're also just going to include what happened in this while checking here, because that's kind of like a variable that controls things. Notice in this code, it's just got the while and then things are pushed in and there's no end while. This is like a Python type coding, I think. I think it was in Python they do it like this, where you don't have the end while like you do in Visual Basic. So that can happen. Like, don't panic that there's not an end while there. Anything that's pushed in is part of the loop, okay? And then when the looping finishes, that's when it drops down and does line 7 and puts out the final total. So anyway, trace tables, remember you want to find out what your start values are. We know our input values are going to be 2 and 6 here. So value 1's 2, and on line 2 it reads in value 2, which is going to be a 6. And line 3 sets our total variable to 0. So we filled them in our trace table. And now we move on further and start looking at 4, 5, and 6. What are those ones doing? So 4 is checking, is value 1 less than value 2? Well, value 1, if we look back up here, is a 2, and value 2 is a 6, and 2 is less than 6, so that's true. So that means because line 4 is true, we're going to be doing lines 5 and 6. All right. Now what I've done here is you can just fill in where they're staying all the same, but that's kind of a bit boring and makes it all busy and cluttered. So this is just another way of doing it. You only kind of fill in that column when something changes. All right, so it started off as 2, and at the moment it's just staying as 2. But when it changes here, we will actually fill it in, but otherwise don't fill it in. I think this is kind of a cleaner way to look at it and makes it easier, but it's up to you which way you do it. Now, line 5, total is going to be the total plus what value 1 was. Well, total was 0, so we grab 0, grab what value 1 was, well, it was a 2, 0 plus 2 equals 2. So total's now going to become 2. That's what's in the memory for total. It's not 0 anymore, it's 2. And line 6 says, okay, let's modify value 1, let's add a 1 to it. So value 1 at the moment, if we check back, is a 2, so we're going to add a 1 to it. 2 plus 1 is 3. So value 1 will now become a 3, and that's line 6 done. And we're going to repeat this while value 1 is less than value 2. So look, here's filling in the trace table all the way to the end. We won't take you sort of through 20 slides doing it. But what happened when we got to here was that value 1 was a 3, okay? And we're checking, is value 1 less than value 2, okay? So it's a 3, value 2 is still a 6. So yep, 3 is less than 6. That means we're going to go for another loop. Did loop 2 here. We're looking for the latest value of value 1. And that's a 3. So 3 is going to add on to the total, and your new total is going to be 5. And then this other line of code, value 1 equals value 1 plus 1, is going to take your 4 and your 3 here, sorry, which it was, and add a 1 on, which will now make that 4. Okay, so that's our second loop kind of finished. Now, it's going to jump back up here and do the while, and it's going to check out value 1 and value 2. Well, at the moment, we've got 4 for value 1, and value 2 is still 6. It's just staying at 6 there. So 4 is less than 6, that's true, so it's going to go through another time. To get the total, remember it adds on value 1. So total was 5, we're going to add on value 1, which is 4 at the moment. That makes that a 9. And value 1 needs to get bumped up by 1. It gets plus 1 on it. So we're going to take our 4 that was here, add 1 on, and that's now 5. We're going to jump back up in the loop. So we've done 1, 2, 3 loops there. Is value 1 less than value 2? Yep, 5 is just less than 6. So we're going to go another time, a 4th time through the loop. And the first thing we do is take our total and add on value 1. Well, total's 9, so we add on our value 1 is 5. 9 and 5 here, 9 and 5 gives 14. And for value 1 equals value 1 plus 1, line 6 of the pseudocode, we're going to take value 1, which is 5 here. We're going to add on 1, and that'll bring that up to 6 for our 4th time through the loop. And then once we've done that, we're going to jump back up in the loop again to the while. Check out the while is value 1 less than value 2. Well, value 1's now got itself all the way up to 6. And value 2 has just been hanging around the whole time being 6. It never changed from its start value. So 6 is not less than 6. They're actually equal to each other, so it's false, which means, yay, we can finally finish all the loop repeats and just jump down to line 7, which says output the total. So in total at the moment, we've got 14. So 14 will just come out on the screen. And that is your final answer, all right? So that's how you would do a loop one, all right? So loop ones are a little bit longer. This one did 4 loops. And you'll see that 4, 5, 6, 4, 5, 6, 4, 5, 6, 4, 5, 6 is repeated 4 times. So it was a 4 looper caused by simply by the initial values we started with. It took 4 lots of loops until this 2 was no longer smaller than the 6 kind of thing. All right, so if you're a teacher or a trainer and you want to give your class some stuff to practice on, go to tes.com, which we've got up here. So TES is a teacher resource thing. I think it started off in the UK. It's now also in Australia. But if you're a teacher or a trainer, you can join up to this for free. So just click on that register for free here up the top right-hand side. And I've registered and joined that. And what I did manage to find was some things on trace tables. So I just searched in the search box on the word trace tables. This one kind of looks okay and it only cost £2, but I didn't actually purchase it because I found this one here, which had some reviews and was rated 4.5 stars and free. And when I downloaded and checked that out, that had some okay stuff in it. It's UK GCSE, computer science, but those courses, I've looked at stuff on the internet before. It's very much the same as our VCE computing subjects, especially like software development here in Australia, so in Melbourne, Victoria, Australia. So yeah, I've just actually got those and yeah, my class is going to work through some of those and a couple other things that I got. So yeah, the downloads for this lesson, this presentation as a PDF is free. This is a free lesson, okay? So you can get that by checking in the YouTube description for the link, but we haven't had time to actually make up our own trace table exercises or go through old exams and pull some out to have a look at or anything to do. So yeah, just jump onto TES, become a member for free, and you'll be able to get it. Check with your teacher, because your teacher may have watched this video already and already got some other stuff or this GCSE UK stuff for you to do. So anyway, thanks for watching. We hope you sort of found that okay to do, and it might take a bit more practice to sort of get used to it, but it is something. There'll definitely be pseudocode on the exam and they'll ask you to work out things, and so you need to know how to do some sort of desk checking with pen and paper, because you will not have a computer there to write a quick little program to test it. You have to be the human computer and draw up little tables and scribble stuff down and use the calculator which you brought into the exam. You are allowed to bring in to do calculations if you're not sure what 3 times 3 is and things like that. If you found this useful, like this video and subscribe to our channel, because we're putting out new videos once a week, and yeah, this will help you with your programming in any language. And next lesson, we're probably going to get back to just doing some more coding and programming in Visual Basic.